Hello, judges, and welcome to our explainer for the NeuroX 1.0 competition. We are Team PullamaiKoodam from the University of Peradeniya, and we are absolutely thrilled to present Project Angadi. Today, we're going to break down exactly how we've engineered a locally run AI solution for a very real and honestly very messy business challenge. So let's dive right in. Here is a quick look at our agenda for today. We're going to cover the B2B wholesale problem, introduce the Angadi trade agent, map out our architecture and workflow, go over our Phase 2 execution plan, and then wrap things up with our final vision for NeuroX. All right, Part 1, the B2B wholesale problem. Picture this. You've got a small wholesale shop relying on just a handful of employees to manage a constant, endless barrage of customer inquiries. And these messages, they are chaotic. Employees are stuck manually deciphering texts that mix Sinhala, Tamil, and English all together. They're riddled with spelling mistakes, weird product aliases, and vague details. From there, it's just a massive manual scramble to check physical stock, verify the latest prices, look up customer history, and deal with suppliers. This totally manual grind leads to slow replies, pricing errors, late reorder decisions, and ultimately lost sales. It's a real bottleneck. Which brings us to Part 2. Introducing the Angadi trade agent. To solve this, we propose Angadi. Now, we want to be super clear here. This is a local AI sales and inventory trade agent, not just your standard chatbot. We designed it from the ground up to be a professional, trustworthy system. Let's look at Part 3, our architecture and tool workflow. Okay, so how does a message actually travel through our system? When an unstructured customer inquiry arrives, it first hits our API boundary, where FastAPI and Pydantic immediately step in to validate the payload. Next, we use deterministic NLP preprocessing to normalize all that mixed language text we talked about, extracting clear quantities and codes. From there, LangGraph takes the wheel. We went with LangGraph for workflow orchestration because, frankly, a single AI prompt just isn't enough for this kind of complexity. We absolutely need persistent state, conditional routing, and the ability to pause the whole thing for human approval. And this brings us to what we call our double model approach. We explicitly use the Qwen 3.8b model twice in this pipeline. First, it steps in for understanding the intent and planning out exactly which tools to use. Based on that plan, LangGraph dynamically routes to our business tools to pull verified facts. Then, and only then, is Qwen 3.8b called a second time to generate a highly controlled draft using strictly those verified facts. After that, it goes through business rule validation, gets employee or manager approval, undergoes a final stock revalidation, executes, and leaves a complete audit record. Now, you might be wondering, how does the AI get those verified facts in the first place? Well, we engineered a really dynamic suite of specific business tools. The product catalog tool handles all those tricky aliases and rankings. The inventory and pricing tool acts as the absolute unquestionable authority on stock. We bring in context using the customer and order history tool, plus the supplier and reorder tool for shortages. Then we have our critical control tools. The approval tool pauses everything for human review. Only after that green light do the stock movement and outbound communication tools actually execute. And wrapping it all up, our audit log service records absolutely everything. We really want to reinforce our human-in-the-loop guardrails here. This is what we call the execution boundary. The AI is there to interpret language and draft text, but it must never, ever directly change stock, set prices, approve discounts, or send messages on its own. People have to remain in complete control of all consequential actions. It's a non-negotiable for us. The system is built for absolute safety. Moving on to Part 4. Our Phase 2 execution plan. For Phase 2, we are ready to build the prototype using a precise, fully local tech stack. The front end will be powered by React, TypeScript, and Vite. The back end is running on FastAPI, Pydantic, and LangGraph. For our local AI, we're using a llama to run a quantized Qwen 3.8b model. And for fast, resilient data matching, we're combining SQLite, SQL aliases, Rapid Fuzz to catch those spelling errors, and optional BGM3 semantic matching. So, what will this prototype actually do? During our demo, you'll see a comprehensive set of features. We'll showcase manual inquiry entry, product matching, and dynamic tool routing in action. You'll watch live stock and price verification, see the AI generate drafts, and route them through our crucial two-level approval system. This all culminates in simulated message sending, safe stock movement, automated low stock alerts, and of course, full audit logging. Finally, Part 5, NeuroX and our final vision. We wanted to share a quick aside on exactly how Team PullamaiKoodam found out about the NeuroX 1.0 competition. It was quite literally through our HOD's mail. And we just want to express our genuine appreciation for this event. We highly value this competition because it actively encourages the development of practical, agentic AI solutions for real, messy business problems, rather than just asking us to build isolated theoretical models. To close out our explainer today, we want to leave you with our core design principle. Angadi understands the request, trusted tools verify the facts, people remain in control, and the system executes only the latest validated and approved action. Angadi, local intelligence for smarter trade. As we rush headfirst into an era of increasingly autonomous tech, we have to ask ourselves, isn't it time we built AI that actually empowers local businesses rather than trying to replace their human judgment? Thanks so much for listening.